Welcome to this Kibana 5 introduction. Kibana is the front end inside the so-called Elastic Stack, and I will guide you through the first steps when visualizing your data with Kibana 5. This video will not cover how to set up Kibana or Elasticsearch. It will neither cover how you insert data into Elasticsearch. I assume you already have a running Kibana 5 instance and data in your Elasticsearch. When you start Kibana 5 for the first time, you will see this screen. Before we can start analyzing data, we will need to tell Kibana what's the name of our Elasticsearch index or indexes we want to view. You need to enter your index name into this text field. I will use some sample web server log data during this introduction. Those indexes are prefixed with logs in my case, so I enter logs-* as the index pattern name. Kibana will now search for all indexes beginning with logs. It's common to have time-based data splitted up to multiple indexes, for example one index per day or per month, depending on what amount of data you have. With this wildcard name patterns, Kibana will find all those indexes. If you don't have time-based data, for example a database of customers or similar, you can uncheck the first option on this page, indexes contains time-based events. If you have time-based data, you now have to select the name of the field that contains the primary time key. In our case, that's the @timestamp field containing the log time, so I select it. Once we've clicked on Create, the index pattern is registered in Kibana and we can use it. In this overview, you will see all the fields, their types, and some additional information. You can add further index patterns on the top left of the page by clicking on Add New. Upcoming versions of Kibana will introduce a new CSV importer so that you can easily import your data via CSV into Elasticsearch directly from Kibana. After we created the index pattern, we can start working with our data. You can access all the different views in the main menu on the left. The Discover view is used to view a list of documents and search for specific documents. The Visualize view is used to create visualizations like graphs from our data. You can add those visualizations to dashboards to have an overview of your data at a glance. Timelion was formerly a plugin and is now built in. It's used to make advanced time series analysis. The Management tab, that's the tab we are currently on, is basically the settings of Kibana where you can add index patterns and tune some advanced settings. The DevTools currently only contain the so-called console, which was formerly known as the Sense plugin in Elasticsearch. You can use it to send JSON directly to Elasticsearch and is more meant for, as the name says, developers or advanced users. We won't cover it in this introduction. Let's look at the Discover tab first. On the top here, you will find the search bar to search for documents. You find options to save, load, and share searches above it. On the left side, you will find a list of all fields that exist in the documents. In the main area of the page, you find a distribution of documents over the time and the actual list of documents in the index. On top of the field list, you can choose what index pattern you want to look at. If we would have configured multiple index patterns, we would click here to see a list of all index patterns and select one. For all time-based indexes, you can choose which time range you actually want to view with the time picker on the top right. You can either set the range choosing a quick option or specify it relative from now or as an absolute time date range. I now want to see the last 24 hours of logs. To watch a document, we can expand it on the caret in front of it. Now you can see all fields in this document, their types indicated by a small icon in front, and their actual value. You also have several actions on each field where you can filter for documents with the same value, where you can exclude documents with a value from the list. You can add this field as a column to the table, which we'll see in a moment, and a last action to filter for documents that actually have this field in the documents, since not all documents inside an index must look the same in Elasticsearch. If you are only interested in some of the fields of each document, you can simply modify the table by clicking on the add behind the field name in the left panel. So, for example, we can add the client IP to the table, we can add a response to the table and the request to the table. You can also add a column to the table by using this column icon shown earlier. If you click on the field name itself, you can also easily see the top 5 values that this field has among all the documents shown. We can use the search bar on top of the page to search for documents. Since queries can be pretty complex in Kibana and highly depend on what way your data was inserted into the index, I will just show you some small examples here. I've written a blog post going in depth on the queries that you can have a look at. If we search for response colon 200, we will get a list of all the documents that had a response code of 200. We could also negate this search by adding an exclamation mark in front of it. So we will see only the documents that didn't have 200 as a response code. We can now save this specific search, meaning the column layout and the query, by clicking on Save on the top right and giving it a name. Let's name it Failed Requests in our case. Important, if you continue making changes to the search after saving, these aren't automatically saved. Even though it might look like because they are stored locally in your browser, you have to hit save again and save it with the same name to persist these changes. To create a new empty search, use the new action, and to open a saved search, use the surprisingly named open action. One of the main parts of Kibana is creating visualizations at the Visualize view. You can either load a previously saved visualization on the right or create a new one on the left by selecting the type of visualization you would like to create. Let's start with a simple pie chart. After you selected the type of visualization, you choose whether you want to use the complete data from an index or the data from a previously saved search. Let's select the logs asterisk index for this visualization. In the visualization editor that you can see here, you have again the search bar on top of the screen and the new save, load, share and the time picker. In the main area you will see the visualization output, which currently is just a circle, because we haven't configured anything yet. In the left panel you will find the actual editor in which you can configure your visualization. If you are completely new to aggregations in Kibana, I recommend you to pause now and watch my other video about aggregations and how they work in Kibana. To split up the pie into slices, you will need to create a bucket aggregation of the type split slices. A bucket aggregation will sort the documents represented in this graph into multiple so-called buckets. You could also describe them as groups of documents. You now have to select a type of aggregation that you want to use to create the buckets. If we want to visualize what file types were requested to what percentage, we can use the terms aggregation and select the extension field. After making any changes in the editor, you have to click the Apply Changes button on top, or you could also discard all not yet applied changes with this button beside it. After we applied the changes, we now have a pie chart about the top 5 extensions and how many requests have been made for them. Most aggregations have some sort of options you can tune in the editor. For example, with the terms aggregation, we can set a limit on how many buckets should be created. We could change this to 3. In that case, only the top 3 extensions will be shown in the pie chart and not the top 5 anymore. The size of each pie slice is currently determined by the amount of documents with that value. We can change this in the matrix aggregation section. The matrix aggregation is responsible for calculating a value for each of the buckets or slices in this chart type, which will then determine the size of the slice. By default, the matrix aggregation is set to count and will just count the documents in each bucket. But we can use this to, for example, not look at the most requested file types, but the file types causing the most traffic at our server. Therefore, we use the sum aggregation and the bytes field, which contains in our sample data the amount of bytes per request. If we apply these changes now, the chart now shows the 3 top extensions and the percentage of bytes they actually transferred. In my video about aggregations, you can find a more detailed explanation of all the bucket and matrix aggregations and how they work. Besides configuring which data is used for visualization, there's an Options tab to change some other settings of the chart. For a pie chart, we can, for example, enable the tasty donut option, so it looks like a donut and not a pie anymore. If we are happy with the way our visualization look, we can save it. The same rules as for searches apply. If you now make any further changes after saving the visualization, you have to save it again to persist these changes. Let's have a look at some of the other visualization types. The line chart is a commonly used other chart type. As you can see in the editor for the line chart, there are now other types available for bucketing in your chart. We won't have the option split slices anymore since it doesn't make sense. So for line chart, let's select the x-axis type and create a bucket aggregation of the type date histogram on the timestamp field. That way we will get a graph that shows our data over time. Beside the field, the interval is an important option that you can configure for date histogram aggregations. It's set to auto, meaning Kibana will automatically determine what range your chart spans in total and what a reasonable size per bucket would be so that the graph don't get too many or too less data points on the x-axis. You can change this to get one x-axis entry per hour or per day, but most of the time auto is a good choice. For the line chart, you also have an options tab to change some of the chart options. For example, you can change the scale of the y-axis from linear to logarithmic, or you can smooth the lines. Most visualization types support nested aggregations. Let's say we don't want to have one line for all documents, but we want to get individual lines per country. We can use the Add Subbucket buttons to add another type of aggregation. We can use the Split Lines type, which will cause each bucket to have its own line. So we use a terms aggregation on the geo.source field and set it to 5, so we will get 5 lines, one for each of the top 5 countries. As we can see in the result and in the legend on the right, we get way more than 5 lines. So what has happened here? Kibana applies the aggregations in the order they are specified here. In our case, that means it first creates a bucket for each time slot on the x-axis. After that, it applies the terms aggregation, which will now find the top 5 countries in each time slot. But that way, each time slot can have other top 5 countries, which does lead us to this huge amount of lines. If we disable the connecting lines, you can see that there are a maximum of 5 points per x-axis slot. There may be even less because within this time there might be not requests from 5 different countries. The solution of this problem is to change the order of the aggregations. You can do this by using the up-down arrow beside the aggregation and drag and drop it into another order. If we apply the split lines aggregation first, we see that now we have only 5 lines, since it first looks up the 5 top countries and then split it up into time slots on the x-axis. Some aggregations also support multiple matrix aggregations. For the line chart, we can add another matrix aggregation that determines the dot size. If we use an average aggregation over the bytes field, we can now see the average bytes transferred in each time slot in each country by the dot size. These nested and multiple aggregations give you great power when visualizing your data. After we've saved this aggregation, we head back to create a new visualization. The area chart and the vertical bar chart are pretty similar to the line chart in terms of their functionality, so I won't look at them now. Let's instead have a look at the data table. The data table shows the result of an aggregation in a tabular format. That way we could create a simple table showing a histogram of transferred bytes in, let's say, 300 byte steps and how many requests transferred that much bytes. We just select the split rows option, select a histogram, select the bytes field and specify the interval of 300. And now you see we get a table that holds the bytes, each byte range from 0 to 300 and the count of documents falling within this byte range. Internally, Kibana creates this table for any visualization anyway. Sometimes it might be useful to inspect that table on any other visualization. To view it, find the small caret below any of the other visualizations and click on it. That way you open the debug panel for the visualization. Besides the raw request and response, you can also view the result of the aggregation as a data table. And you can even export it to CSV. So let's create a new visualization. If you want to write some static introduction or similar to a dashboard later, you can use the Markdown widget. It's just a basic text field that allows you to write some Markdown that you can later add to a dashboard. That way you can, for example, write introductions or add some links to other tools onto your dashboards. The metric visualization allows you to just output the result of one or multiple metrics aggregations. As already mentioned earlier, there is a search bar on top of the visualization editor. We can use this to further narrow down the data that is visualized. If we search now for response equals 404, our metric will only show the count of all 404 requests instead of all requests in the selected time range. We can also specify custom labels to each aggregation. These will be used depending on the visualization type as axis labels or similar labels. If we save a visualization with a query entered, that query is stored with the aggregation, which is important once you place it on a dashboard, as we will see later. The tile map aggregation is a bit different from the classical charts that we've looked at so far. It can be used to visualize data containing geo-coordinates. So the only aggregation available is the geohash aggregation, which will create buckets for data that is close to each other. You can use the Fit Data Bounds icon on the map to zoom the map to only that area that contains data. For the most use cases, I would recommend leaving the Change Precision on Map Zoom option enabled. That way Kibana will automatically create more granular bucket once you zoom in. In the options of the map, you can also switch the representation from the default scaled circle markers to, for example, a heat map. Once we save this, we look at the last type of visualization. The last type of visualizations are time series. Those are used so that you can place timeline charts on a dashboard. So let's have a short look at timeline. Since timeline is pretty powerful but also complex, I will only cover the very basics in this introduction and refer to a more depth explanations in the description of this video. Let's also switch to the last 24 hours in timeline, which currently has a separated time picker. And as we can see, timeline uses a custom expression language that we use to create charts. It is capable of doing several charting tasks that you cannot achieve with aggregations easily. For example, I want to see the traffic of my server and see it directly in comparison to the traffic the day before. This isn't possible easily with aggregations. To get data from Elasticsearch, there exists the .es function that you can already see up here. If we just want to filter for successful calls, we can use the queue parameter and specify the query of response equals to 100 as we've seen earlier. With timeline, we can easily add multiple data into the same graph by adding a second ES function. As you also see, there's a help dialog while typing functions that show you what functions exist and also the parameters they accept. To get the same data, but offsetted by 1 day, we will use the same query again and use the so-called offset parameter and use a value of -1 day. That way, we have now two curves, one being the current data and the other one being the data from the day before. We can use the .label function on each of the curves to give their more saying names. If we want to add them to a dashboard, we can use the save function and select save current expression as Kibana dashboard panel and specify a name for the panel That way, we can now add it to a dashboard. That is the same as if we would have created a new time series visualization in the Visualize tab and entered the expression there. I just find the auto-completion is working better in the timeline view, so I would prefer using this instead the Visualize view. Now we've created several visualizations, so we can head over to the last part of this introduction, creating a dashboard. If you haven't created any dashboard yet, you will start with this empty view. Use the Add button on top to add previously saved visualizations. Let's add all the visualizations we have created so far. We can also use the Searches tab to add saved searches, which will then basically add the result table to our dashboard. We can remove any of the visualizations by hovering over it and use the small delete icon on top right. We can also use the move icon to move all the visualizations over the dashboard and use the top right corner to scale them. Once we are happy with the layout, we can save the dashboard. You can use the Store Time with Dashboard option to save the currently selected time range from the date picker with the dashboard. We can also share saved dashboards under the Share menu. On the left side, you will see all the links to embed via iframe or share the saved dashboard. So this link will always load the latest saved state of the dashboard. On the right side, you will find links that will always share the current state of the dashboard, whether it's saved or not. This link won't load any new changes if you touch and save the dashboard after sharing this link. Since those links are quite long, there's an option to shorten the URLs. The option panel also gives you a quick option to switch to the dark side. So let's go back to the last 2 days also in this view again. The dashboard also has a search bar on top of it. As mentioned earlier, the searches made in visualizations are saved with them, meaning the not found metric still shows the amount of documents with response 404 even if I don't enter anything in the dashboard search. If I start searching on the dashboard, those search queries will be merged with all the queries of the visualizations. As an example, if we search for response equals 200, the 404 not found metric will now show 0 because there are simply no documents where the response is 404 as requested by the visualization and 200 as requested by the dashboard at the same time. The timeline visualization we saved doesn't change at all since we already had the response 200 saved in this graph. You can also use the graphs directly to filter deeper into your data. For example, clicking on a slice in the donut chart, you create a filter for the value of this slice. The filters will appear on top of the dashboard. You have the options to temporarily disable the filter, you can negate the filter, and you can also remove it from the dashboard again. With the Draw on Rectangle option on any map, you can filter into the location of your data. So using this, we have now filtered all the data that lies within the drawn rectangle. It also creates a filter on top that we can simply delete afterwards again. Charts with the time on their x-axis can be used to change the time range of your dashboard by just selecting it like this. This won't create a filter rather than the others, but just change the time set via the time picker up here. If you want to use your dashboard on some screen as kind of monitoring, you can also enable the auto refresh option once the time picker is expanded. You can go to auto refresh and select, for example, 10 seconds. That way the dashboard will now continue to refreshing automatically every 10 seconds. Now you've seen all the basics you need to use Kibana 5 and start visualizing your own data. If you have any further questions or requests on specific topics you would like to see in more detail, please feel free to leave a comment below. See you the next time and enjoy your Kibana 5.